Objects in low Earth orbit travel at 17,000 miles per hour. At that speed, human reaction times are useless against a sudden cloud of debris. Because of this, satellite operators are increasingly taking their hands off the wheel, letting artificial intelligence execute split-second autonomous maneuvers to protect our orbital infrastructure. Down here on Earth, artificial intelligence operates within a reliable safety net. If an autonomous system encounters a problem, it relies on massive datasets of historical patterns to correct itself, or an engineer simply hits a kill switch. But as this diagram illustrates, terrestrial logic completely collapses in the celestial vacuum. On the left, a server rack faces quantifiable risks. On the right, chaotic orbital reality offers zero real-time human intervention. Historical data provides no predictive value against cosmic radiation. Deploying hyper-intelligent systems into this environment without updated rules poses an immense risk. A single autonomous miscalculation can generate high-speed shrapnel, triggering a cascade that dismantles the satellite networks our modern society relies on. A 2019 survey analyzed 84 major global AI ethics guidelines. When evaluated for extraterrestrial deployment, exactly 0 of them were applicable. We are launching autonomous machines into the dark with an absolute regulatory vacuum. We are entering Knightian uncertainty, moving past calculable risk into unknown unknowns. The Socratic bust reminds us we know almost nothing about how these systems behave long-term. As the cosmic variables show, physical sensors warp under radiation, creating unpredictable emergent behaviors. If an AI makes a catastrophic decision under these conditions, it could trigger Kessler syndrome, a runaway chain reaction of satellite collisions. This would shred orbital planes, wrap the Earth in an impenetrable cloud of shrapnel, and permanently trap humanity on the ground. To establish rules for the void, Fabrizio Degni developed the PALO Framework. Built on 7 core ethical principles, it governs machines operating off-world. Moving down the diagram, graduated cosmic ethics requires governance to scale dynamically based on physical distance and communication delays from Earth. At level 1, the distance to the Moon creates a mere 1.3-second communication delay. Direct human presence is possible here, and a traditional human-in-the-loop model works perfectly. Mission control can monitor the AI and overwrite it almost instantly. But at level 2, distances to Mars create a communication lag of up to 24 minutes. If a rover is about to drive off a cliff, Earth won't even know it happened until a half-hour later. This forces a shift to a human-on-the-loop model. Here, the AI acts autonomously within predefined boundaries, requiring agentic compliance, internal software that continuously verifies the machine follows safety rules without waiting for human approval. The further we travel, the more physical distance strips away our ability to intervene. Deep space exploration requires machines that possess the internal ethical architecture to make responsible choices entirely on their own. This brings us to level 3, operations near outer planets like Jupiter's moon Europa. Here, delays stretch past 80 minutes, pushing systems into a state of guided autonomy, where the machine operates deep beneath kilometers of ice, entirely cut off from Earth. Imagine a probe drilling into the European Ocean. The onboard AI suddenly detects chemical signatures pointing to extraterrestrial life. But at that exact millisecond, a structural alarm goes off. The drill is failing, and the hardware will be destroyed if it doesn't withdraw immediately. The machine cannot pause and ask Houston what to do. There is no terrestrial kill switch. It must choose, in a fraction of a second, between capturing the greatest scientific discovery in history or saving its billion-dollar hardware. The PAL framework addresses this impossible choice during its Phase 2 comprehensive assessment. Long before launch, engineers and ethicists map out these extreme scenarios and hard-code humanity's moral priorities, evaluating the exact trade-offs between scientific discovery and mission survival, directly into the machine's cognitive architecture. True autonomy in the cosmos means we cannot rely on hindsight. We have to anticipate our deepest values and encode them into the machine before the rockets ever ignite. Effective space governance cannot rely on reactive laws. It must be an architectural feature, hard-coded directly into the processors of orbital servers and deep space probes. First, space agencies must adopt PALO's Phase 1 screening as a mandatory gate. Next, the UN must convene a space COP to execute a kill list, eliminating every terrestrial workflow, legacy system, or manual override prone to failure under the radical uncertainty of space. The vacuum of space is inherently lethal. Establishing regulatory certainty in an environment trying to destroy your hardware demands rigorous structural cooperation on an international scale. The PALO framework transforms AI into an agency-amplifying system rather than imposing limits on scientific progress. As private companies and national agencies push toward off-world manufacturing and hyper-automated satellite networks, this framework guarantees that the business of space remains strictly human-centric, answering to our standards even when humans are millions of miles away. To safely explore the absolute unknown, we have to encode our humanity into the dark. Because, as Degny states, we must govern the void before the void governs us.